Hello everyone, this is Swathi, working as Assistant Professor in the Department of Electronics and Communication Engineering in Institute of Aeronautical Engineering, Dundigal. Welcome to this lecture. In this lecture, we'll be discussing some definitions and terminology from Module 1, that is regarding PN junction diode. So first of all, we will discuss some basic definitions related to the Module 1, that is on PN junction diode. So first one, define electronics. So what do you mean by electronics? So it is a branch of engineering which deals with the conduction of current through vacuum or a semiconductor. So here this deals with the conduction of current through vacuum or gas or a semiconductor is nothing but electronics. And conductivity, what do you mean by conductivity? It is the property or else ability of a metal or material to conduct electricity when a potential difference is applied. So when a potential difference is applied, whatever the amount of current that can be flowing through the metal or material is known as conductivity. Or else it is the ability of the material or metal to allow the flow of current is called as conductivity. And what are the units for this conductivity? Conductivity is defined as the inverse of resistance. So conductivity is represented with sigma and it is defined as the inverse or else reciprocal of resistance, and it is nothing but 1 by ohms, or else we can also call it as mhos. So these are the units for conductivity. Now coming to the voltage. How can we define a voltage? The potential difference between any 2 points in an electric field is defined as the voltage. So if there exists 2 points, whenever some electric field is existing and whatever the potential difference between the 2 points is called as voltage. So that is V1 minus V2 in the presence of electric field is known as voltage, and the units for voltage are volts. So these are the units for voltage. Now coming to the current. How can we define the current? So current is defined as the flow of charge carriers from one place to the other place is defined as the current. So whenever the charge carriers, either these are electrons or holes, whenever they are moving from one point to the other point, then there exists a current. So that is known as current. And here usually electrons are electron deficient atoms, nothing but holes. Electron deficient atoms means holes. So these are the carriers which are nothing but charge carriers, where they whenever the electrons and holes are moving from one place to the other place, it leads to some current. And coming to the units here, the units for current are amperes, and this is represented generally by I. Okay, so or else we can also define it as Q by T. The charge per unit time is also defined as current. Okay, so this is the current. We can also define the units as coulombs. What are the units for charge? That is coulombs per milliseconds or else seconds. So these are the units. Or else we can also measure this current in terms of amperes also. In terms of amperes. So this is current. And resistance. How can we define a resistance? Resistance is nothing but a property which can oppose the flow of electrons. That means which can oppose the current flow is known as resistance. So here the resistance is given by R is equals to V by I, where V is the voltage and I is the current, where voltage is measured in volts and current is measured in amperes, or else we can also measure this resistance as ohms. So that means it is the property of a metal or material which through which it can oppose the flow of charge carriers, either that may be electrons or holes. It can oppose the flow of charge carriers. So that is resistance, and the formula for resistance is V by I, where the units are volts per ampere, or else we can also measure it as ohms. These are the units for resistance. Now coming to the next one, circuit. How can we define a circuit? What is a circuit here? Circuit is nothing but the interconnection of number of components along with the power sources and signal sources such that it can form a closed loop. or else number of components connected in a closed loop is known as circuit, and the components may include resistors, inductors, capacitances, and also the power sources or signal sources. That means either you can have voltage source or current source. So all of them connected together in order to form a closed loop or else a complete circle is known as circuit. So circuit is a word which comes from the word that is circle. So that means all the components are connected in a closed loop. So for example, we have a circuit like this. We have a resistance and capacitance, and we do have a voltage source. So this is nothing but a circuit where it is forming a closed loop. So that means all the components, including resistors, inductors, capacitors, and the sources, signal sources, connected together such that a closed loop is formed or else a circle is formed, is known as circuit. Coming to the electronic circuit. What is an electronic? Define an electronic circuit. An electronic circuit is composed of individual electronic components such as resistors, transistors, capacitors, inductors, diodes, and whatever it is. So that means it is a combination of active and passive elements. So that the active and passive elements, the diodes and transistors will be coming under active devices, whereas the passive devices are resistor, capacitors, and inductors. So electronic circuit is composed of individual electronic components such as resistors, transistors, capacitors, inductors, and diodes. Now coming to the conductor. How can we have basically three types of materials. So what are those? Conductors, insulators, and semiconductors. Based on the type of conductivity or else based on the amount of current that is flowing through that material, we can classify the materials into three types. First of all, let us see what is a conductor. A conductor is a material which has very high conductivity and very low resistivity. So as you know that conductivity is inversely proportional to the resistivity. Resistivity is the property of a material which can oppose the flow of current, whereas conductivity is the property of a material which can allow the current to flow. So that is why a conductor is a material which has very high conductivity. And in other way, we can also define it as, we have in energy band diagram, we have valence band as well as conduction band. The gap between the valence band and conduction band is called as forbidden energy gap or else energy gap. Okay, forbidden energy or else energy band gap. So here, if the material in which the gap between the valence band and conduction band is almost zero, and if they are almost overlapped, so for example, this is valence band and conduction band, if they are almost overlapped, that means the gap between the valence band and conduction band is zero, then such type of materials are also called as conductor. So we can have different types of definition here. A conductor is a material which has very high conductivity and very low resistivity are defined as conductor. And the examples for pure conductors are copper, aluminium, and silver. Now coming to the semiconductor. So semiconductor is a material that has its conductivity which lies between the conductivity of insulator and conductor. That means it is the conductivity of semiconductor is less than the conductor and it is greater than the semiconductor. And the examples of pure semiconductors are silicon and germanium. And the gap between the valence band and conduction band is high when compared to the conducting materials, and it is approximately equals to 1.1 electron volt. Okay, so this is about semiconductor. So that means the current flows moderately when compared to the conductor. As the conductivity of conducting materials are very high, the amount of current flowing through the conductor is very high. Now coming to the electronic circuit, define electronic circuit. So already we know that, sorry, it is not electronic circuit. Define insulator. So define insulator. So what is an insulator? So insulator is a material that offers very low level of conductivity when a voltage is applied. So conductivity is very high. For semiconductor, it is having moderate conductivity that lies in between the conductor and insulator. Whereas insulator, it is having very low level of conductivity. As the conductivity is very less, there is no current flow through the insulating material. So that is why we always use these insulators wherever we need to provide insulation from the electric supply. That means wherever we need to avoid the electric shocks and all, we'll be using this insulator, because in insulator there is no flow of current. Okay, because its conductivity is very low. And also we can see that as the conductivity is very less, it has high resistivity. It has high resistivity. So these are this is about the insulator, and the examples of insulators are wood and glass. So these are the examples where the current not at all flows through this material. Now coming to the semiconductor. So again, we have two types of semiconductors. We can classify the semiconductors into two types. Those are intrinsic semiconductor and extrinsic semiconductor. What do you mean by intrinsic semiconductor? The pure form of semiconductor is called as intrinsic semiconductor, and the examples of semiconductors, that is intrinsic semiconductors, are silicon and germanium. So that means in intrinsic semiconductor, the carrier concentration will be uniform. So that is why it is intrinsic semiconductor. So now coming to the extrinsic semiconductor. So extrinsic semiconductors are nothing but the current conduction capability of intrinsic semiconductor can be increased significantly by adding a small amount of impurity to the pure semiconductor. So the intrinsic semiconductors are also called as pure semiconductors. So if you add some impurities, why we need to add impurities? In order to improve the current conduction capability. We will be adding impurities to the semiconductor, intrinsic semiconductor, which will give us extrinsic semiconductor. So that means impure form of semiconductors is known as extrinsic semiconductor, and we are adding the amount of impurities to the pure semiconductor, and the process of adding impurities to the pure semiconductor to get the extrinsic semiconductor is known as doping. So that means if any intrinsic semiconductor is doped with some impurities, then it will give you extrinsic semiconductor. So the extrinsic semiconductor are again two types. Those are N-type and P-type semiconductors. So that we will be discussing. So first of all, let us define a diode. What is a diode? A PN junction diode is a basic semiconductor device that controls the flow of electric current in a circuit. So PN junction diode is a basic semiconductor device. It is a two-terminal device, whereas the two terminals are that is anode and cathode. So PN junction diode is a basic two-terminal semiconductor device that can control the flow of electric current in a circuit. Now let us define what is a static resistance. So the static resistance of a diode at a particular point, or else the resistance of a diode at a particular operating point is called as DC resistance, or else we can also call it as static resistance. That means under the influence of DC input voltage, whatever the resistance measured at a particular operating point is known as static resistance or DC resistance, and it is represented with, that is, V by I. So this is, and the units for static resistance are, again we know that anyhow whether it is a static or dynamic resistance, then units of resistance will be ohms. Now coming to the dynamic resistance. So the dynamic resistance is measured between 2 points. For example, these are the characteristic curves of PN junction diode under forward bias condition. So if you measure the voltages and currents at any 2 points on a characteristic curve, let us indicate this one as I2 and this one as I1, this one as V1 and V2. Then The resistance, AC resistance or dynamic resistance, which is represented as small r, is defined as the change in voltage, that is dV by di, that is V2 minus V1 divided by I2 minus I1. So anyhow, this is also measured as ohms. So it is determined by a straight line drawn between the two intersections of the maximum and minimum values of input characteristics. And here this is represented with small r, which is given by dV by di, or else in other way we can also define the dynamic resistance or AC resistance as the change in voltage with respect to the change in current, and the units for this one are also ohms. Okay, and here this is the dynamic resistance, and why we are calling this as AC resistance, and this is measured under the application of AC input signal to the diode. So that is, we need to measure the maximum values of input voltage and input current, and then we have to take the ratio between them. So that is dynamic resistance. Now coming to the drift current. So drift current is the electric current or movement of charge carriers which is due to the applied electric field, often stated as the electromotive force over a given distance. So that means, for example, under the applied voltage of under the applied voltage or else under the applied electric field. So what happens whether it is a forward biased or reverse biased PN junction diode? So the charge carriers will be moving from one place to the other place. The process of motion of charge carriers from one place to the other place is known as diffusion. Is known as diffusion. So that is due to that will leads to some current which is known as diffusion current, whereas the drift current is the current due to the applied electric field or else and it is due to the motion of or movement of charge carriers is called as drift current, and this is also called as electromotive force. Coming to the diffusion current. So here, diffusion. So what do you mean by diffusion? So here, whenever we consider a PN junction diode, so the P type is having more number of holes. Holes are the majority charge carriers, whereas electrons are the minority charge carrier. When you take the N-type material, electrons are the majority charge carriers and holes are the minority charge carriers. Holes are very less in number in case of N-type semiconductor. So always the charge carriers will be trying to move from higher concentration to the lower concentration in order to maintain the neutrality. So that is why the holes will be trying to move from P-type to N-type and electrons will be trying to move from N-type to P-type, because the electron concentration is more in N-type material and less in P-type material. So this process is called as diffusion. So always the charge carriers will be trying to move from higher concentration to the lower concentration. So due to this concentration gradient, there is some diffusion of charge carriers one place to the other place, which leads to some current that is called as diffusion current. So diffusion current is a current in a semiconductor caused by the diffusion of charge carriers, and this is the current which is due to the transport of charges occurring because of non-uniform concentration of charged particles in semiconductor. That means we can replace this non-uniform concentration as due to the concentration gradient. I can replace this entire sentence, that is a word, as due to the concentration gradient, always the charge carriers will be moving from one place to the other place, that is higher concentration to the lower concentration, and the process of diffusion of the movement of charge carriers due to the concentration gradient is called as diffusion, and the current which is flowing to the due to the diffusion of charge carriers is known as diffusion current. Now let us define a capacitance. Capacitance is an ability of component or a circuit to collect and store energy in the form of electric field. So we all know that capacitance stores the energy in the form of electric field. So that is when it is the ability of a component or circuit to collect and store the energy in the form of electric charge. Diffusion capacitance. Define diffusion capacitance. Diffusion capacitance is the capacitance due to the transport of charge carriers between two terminals of a device. So, as we all know that what is the diffusion? In diffusion, what is happening? Due to the concentration gradient, the charge carriers are moving from one place to the other place. That is higher concentration to the lower concentration, due to which there exists some capacitance, and that capacitance is called as diffusion capacitance. So here we all know that capacitance is nothing but when two oppositely charged plates are placed together, separated by some insulating material, is nothing but what? Capacitance. So whenever we consider a PN junction diode, so what happens? This is P-type and N-type semiconducting material. So due to the motion of charge carriers, that is holes from P-type to N-type and electrons from N-type to P-type. So what happens? More negative immobile ions are forming a layer on the P side of the junction, and a layer is formed with positive immobile ions on the N side of the junction. So here this is nothing but immobile ions, so which prevents the further motion of charge carriers. So that means I can say that this is an insulating material, whereas we have holes here on the P side and we have electrons here on the N side. So as the electrons are negatively charged, there is more negative charge on N side and positive charge on P side. So that means these two acts as oppositely charged plates separated by insulating material. So that is why there exists some capacitance in the junction, that is PN junction diode. And here whatever the capacitance that is existing in the under forward bias condition is called as diffusion capacitance. Okay. Under reverse bias condition, what is the difference between that? Under reverse bias condition, the width of the depletion region will be more. So that is why the width will be more, and hence we are calling it as transition capacitance. So the capacitance that is existing in forward biased PN junction diode is called as diffusion capacitance, and this is due to the transportation of charge carriers between the two terminals of device. Now coming to the transition capacitance, the amount of capacitance changed with increase in voltage is called as transition capacitance. So CT is given by dQ by dV. So the change in the charge with respect to the change in the voltage is called as transition capacitance, and this is the capacitance existing in the reverse biased PN junction diode. Reverse biased PN junction diode. Now that is about transition capacitance and diffusion capacitance. Now let us see what is a load line. So how can we define a load line? So a load line is a line or a straight line. Okay, load line is a straight line which is a straight line drawn on the characteristic curve or graph of the current versus voltage in a non-linear device like a diode is known as load line. So a straight line drawn on the characteristic curve, that may be either forward bias characteristics or reverse bias characteristics. A straight line drawn on the characteristic curve or a graph which is drawn between the voltage and current in a non-linear device like diode, transistor and all is known as load line. Storage time. What is the storage time? So these are all the definitions related to the transition diode as a or else diode switching times. So Storage time, the period for which the diode remains in the conduction state even in the reverse biased state is called as storage time. So here actually when we apply this kind of input signal to a diode, so what is happening? As a voltage is changing at this point, as a voltage is changing, suddenly the diode will not be, so during the this is voltage is positive, so now it is becoming zero, means what? It is becoming negative, means what? The diode has to be reverse biased. When the diode is reverse biased, it should be off. So but what is happening? The diode requires some time in order to change its state from on to off, and that time is called as storage time. In another way, we can define the time period for which the diode remains in the conduction state, even in the reverse biased state, is known as storage time. So it requires some time, and that time we are calling it as storage time in order to change its state from conduction to non-conduction state. Now coming to the transition time, the time elapsed in returning back to the state of non-conduction, that is steady state reverse bias, is called as transition time. So in order to achieve the time taken by the diode in order to achieve its steady state reverse bias condition, that means in order to make the diode to off or is non-conducting, is known as transition time. So this is transition time. Now coming to the forward recovery time. So forward recovery time is a time required for the diode to change from reverse bias to the forward bias, is known as forward recovery time. So in order to change the state from reverse bias to forward bias, is known as forward recovery time. So this is forward recovery time. Coming to the reverse recovery time, it is nothing but opposite to that of forward recovery time. So what is a forward recovery time? It has to change its state from reverse bias to the forward bias. Now reverse recovery time is a time required by the diode to change its state from forward bias to reverse bias, is called as reverse recovery time. So to change from conducting to non-conduction is known as reverse recovery time, whereas non-conduction to conduction is known as forward recovery time. So now we'll see what is a rectifier. So rectifier is an electronic circuit that converts AC voltage of main supply into pulsating DC voltage using one or more PN junction diode, is called as rectifier. An electronic circuit which is converting AC voltage from main supply into pulsating DC with pulsating DC voltage, making use of one or more PN junction diodes, is called as rectifier. So why we need to convert the AC supply? So in our houses, we will be getting AC supply, right? So which is of sinusoidal in nature, whose amplitude is 230 volts and the frequency is 50 hertz. And all the electronic appliances which we are using in our house or any industries are requiring only DC supply. So what we need to do, we need to convert the AC supply which we are getting from the main into DC. So this is a major block which is going to convert the given AC supply into pulsating DC. What do you mean by pulsating DC? It is not the pure form of DC. It also includes some AC components. So AC plus DC is nothing but pulsating DC. So that means not only consisting of ADC components, it also includes some AC components. So that is why it is called as pulsating DC. And a circuit which converts the AC supply into pulsating DC is known as rectifier, where the major component that can be used in rectifiers are PN junction diodes. We can use one or more PN junction diodes in order to implement rectifier. Now coming to for every rectifier, we have some specifications or else performance characteristics. Those are, the first one is peak inverse voltage, that is PIV. We can also call, in short, we can also call it as PIV. So the peak inverse voltage or peak reverse voltage is a maximum value of reverse voltage which occurs at the peak of the input cycle when the diode is reverse biased. So this is peak inverse voltage. In other way, we can also define the peak inverse voltage as the maximum reverse voltage that a diode can withstand without any damage, is also defined as the peak inverse voltage. So in the reverse bias condition, what is happening? If you are increasing the reverse voltage, at one point of time, breakdown occurs. So if breakdown occurs, what happens? More current will be flowing. So the maximum voltage the diode can withstand without any damage to the device is known as peak inverse voltage. Coming to the ripple factor. So as I told you that the rectifier outputs consists of AC component plus DC component. But what is our aim? I want to convert the given AC supply into DC. So that means I don't want these AC components to be present in the output. So that is why these AC components are unwanted components, or else we can also call these unwanted components as ripples. Okay, so now define the ripple factor. How can we define a ripple factor? The ratio of root mean square value of ripple voltage to the absolute value of DC component of the output voltage. That means we can also define this as, we can represent the ripple factor as gamma VRRMS divided by VDC. What is VRRMS? RMS value of ripple voltage. That means some AC components are present in the output. So the AC components are measured using RMS value, which is nothing but the root mean square value. So that root mean square value of ripple voltage to the DC value, or its average value of the output voltage, is defined as the ripple factor. So ripple factor must be very low, such that all the AC components should be eliminated in order to design, or else in order to convert the given AC supply into DC. Coming to the efficiency. So efficiency, in general, we can define the efficiency as a ratio of output to the input. So when coming to the rectifier, the efficiency signifies a level of performance that describes using the least amount of input to achieve the highest amount of output. Or else we can also define this efficiency of a rectifier as that what is the output that we require? It should be DC, right? The DC, it is defined as a ratio of DC output power delivered to the load to the AC input power of the transformer secondary. So this is PDC by PAC, and it is always measured in terms of percentage into 100. The maximum output or DC output voltage delivered to the load to the AC input voltage from the transformer secondary is known as efficiency. Now coming to the form factor. So what is a form factor? So form factor is of an alternating current waveform, is a ratio of RMS value to the average value. RMS value nothing but root mean square value, whereas average value is nothing but the mathematical mean of absolute values of all points on the waveform. Or else we can also define this form factor as, we can represent the form factor as F, and it is defined as the ratio of VRMS divided by VDC. So this is the form factor. Coming to the transformer utilization factor. So it is defined as a ratio of DC power delivered to the load to the AC power rating of the transformer. So the transformer we will be using in rectifier. So what kind of transformer we'll be using? We are using step down transformer in order to decrease the input voltage level from 230 volts to some lesser voltage. So whatever the transformer AC rating we are measuring, that is VAC, okay, or else PAC, that is a transformer or else AC power rating of the transformer to the DC output power delivered to the load as transformer utilization factor. So that means the transformer recommended value for of transformer utilization factor for any rectifier is, it should be high, because maximum amount of power should be delivered from the transformer should be utilized in order to convert it into DC. So that is why transformer utilization factor should be very high. And define cut-in voltage. What is a cut-in voltage? The forward voltage at which the current through the PN junction diode starts flowing or it starts increasing rapidly is known as the knee voltage or the cut-in voltage. So this is the definition for cut-in voltage. We can also define the cut-in voltage in another way, that is the minimum voltage required by the PN junction diode in order to conduct is known as cut-in voltage. So once the applied voltage is exceeding the cut-in voltage, the diode starts conducting. Diode starts conducting means more current can flow through the PN junction diode. Now coming to the voltage regulation. What do you mean by voltage regulation? Define voltage regulation. It is a factor which tells us about the change in the DC output voltage as load changes from no load to full load condition. So this is voltage regulation. So whenever you are changing the load from no load to full load, so the change in the output voltage is known as the voltage regulation. So that means how much amount of DC output voltage is obtained with respect to the changes in the load is known as voltage regulation. Coming to the filter. What is a filter? Define filter. How can we define a filter? So filter again is an electronic circuit composed of inductor that is LC and LC components, that is inductor, capacitor, and the combination of inductor and capacitor components connected between the rectifier and the load so as to convert the pulsating DC into pure DC. So when we can say that the pulsating DC is converted into pure DC when the AC components are completely removed. So that means filter is an electronic circuit which is used to, in this particular application, which is used to remove the AC components present in the output of the rectifier. Okay, so it is an electronic circuit which can be constructed using inductor, capacitor, or else a combination of inductor and capacitor components connected between the rectifier and the load so as to convert the pulsating DC into pure DC. Now define pulsating DC. Pulsating DC, that is pulsating direct current, is a periodic current which changes in value but never changes in direction. Or else we can also define the pulsating DC as a combination of DC components and AC components is also defined as the pulsating DC. Or another definition is the pulsating direct current is a periodic current which changes in value but never changes in direction. So these are all the definitions that we can come across in the PN junction diode, that is from the module 1. So this we have to be familiar. These are all the definitions and terminology that we have used, that we can come across in the module 1, which is PN junction diode. I hope it is clear to you all. That's all for this lecture. Just go through the definitions once again, and it is very simple. So I have mentioned all the definitions and all the terminology that we are coming across. So I hope it is clear to you all. That's all for this lecture. Thank you everyone.
Like, share and subscribe. Hit the bell icon for more updates.